Good afternoon, everyone. My name is Bharath. I'm an engineer at Walmart Labs. In this journey of Codable, I would like to share the current data serialization methods that we have today, Codable and internal features, and of the examples to understand the flexibility it offers to customize for other use cases. So one of the famous Nobel laureate once said, if you want to understand today, you have to search yesterday. Data has been playing an important role in almost all the applications in our day-to-day life. And so is the data storage. So we need to store data to retrieve and transmit over the network. Speaking about data storage and interesting factors, there are certain things which played an important role at one point of time, and it became obsolete the next moment. The same goes for some of the APIs that we use for data serialization. So what is data serialization? It's a process of translating the native objects into a format which can be stored, or it can be transmitted over a network. Sometimes it goes by the name marshalling or encoding, which we are quite familiar with. And deserialization is a process, it's a reverse process wherein you take the data and put it back into its native format. Just to give an example, if you want to take an example of a movie, we all love movies, don't we? So if you want to represent it in the form of an array or in the form of a structure or a class, and if you want to store it somewhere, you cannot store this class or structure. You have to serialize this, and similarly, you have to decode it to put it back into its original format. So there are multiple options that we have today, depending on the type of data. One which stands out is NS coding. It's a lightweight Objective C protocol. It's available since available since iOS 2, and it does pretty well for Objective C types, the one which conforms to NS objects, but it doesn't do justification for Swift, whose USP is type safety. And if you have to use structures and enumerations of Swift, it doesn't work well. And one important part is there are no default error handling which NS coding supports. So we want something which provides first-class serialization for not only for reference types but also for value types, and which is type safe, which has ease of usage, and of course customizable and flexible. The important part is it shouldn't have we shouldn't end up writing a lot of boilerplate code, or I can say minimum boilerplate code just to serialize the data. And that's how the Codable was introduced. So some of the unique characteristics of Codable, the compiler provides default implementation for us. We are looking for a motivation to upgrade your Swift if you are still in the older version of Swift. If you upgrade to 4.1 onwards, you get automatic synthesis for equatability. And if you have something like this, you need not have to write an equatable for your objects. And similarly, it goes for hashability. It provides a default synthesis for hashable types. And automatic conformance is provided by default. So what this means is if you have an object of your own type, and if all your members conform to Codable, it by default conforms to Codable. So you need not have to ensure that all the types which are part of your custom types needs to go through a serialization process. Excuse. So if you want to understand what all are supported by default, everything which comes under standard library types, which includes different flavors of int, different flavors of unsigned int, string, double, bool, and float. An interesting part is if you take a look at the source code of Swift in this particular file location, all these standard library types are defined in an array. And you might be wondering, like, what is this .gyb sitting in a Swift source code base? So for those of you who are not quite familiar with gyb, it stands for generate your own boilerplate. So here the Swift generates boilerplate for us for all these basic types. So a default implementation goes like this. For every type that is defined in this array, gyb defines a Python script which has some predefined templates, and you loop through this array and get the default implementation for each of your standard types. So if you are wondering, are these the only types which are supported? No. So along with the standard types, there are some of the foundational types which supports Codable by default. That includes date, data, URL, array and dictionary, all these Codable types, and also optional. So we have been speaking about Codable for quite some time, but what's under the hood of Codable? So Codable is not a protocol in its own, it's just a type alias for a composition of two other protocols called Encodable and Decodable protocol. So Decodable protocol defines a blueprint. If I get a decoder, I'll initialize myself with a possibility of throwing an error. So naturally, the next question is, what is a decoder or an encoder? So encoder and decoders can be categorized into containers. So they provide a container which can be grouped into three categories: a keyed container, an unkeyed container, and a single value container. A keyed container is like primarily used for dictionary types which has keys. An unkeyed container contains an array, and single value container if you want to serialize a single value like string, float, double, number, and null, or just an empty. So if you notice, there is a type called key decoding container which accepts a type. So this key is nothing but a protocol called coding key. It has a string value and an int value. Depending on the type of the container that you deal with, it has its own importance. So with that, let's take a small example how to decode this particular JSON or the data that we have today. So it just lists out a movie for which Best Director won an Oscar in the current year. So if you want to represent it in a model, you consider a structure and just conform to this decodable protocol, and that's it, you are done with it. You need not have to do anything. You no need to write any boilerplate code. So compiler generates a coding key for each and every type here, every member that is defined inside the struct, and it provides a default implementation to deserialize the data. So one thing to note is, like many of the use cases, we just go ahead and conform to Codable. There's no need to conform to Codable. You can just conform to decodable if you are decoding, and encodable if you are just encoding. So let's consider the same JSON, but if the JSON is represented in a different format, there are different format like this, a camel case, and this qualifies for a snake case. The Swift compiler provides, a default option to encode some of the popular types. By default it is camel case, and if you want to decode or encode or serialize and deserialize, you can just subscribe to you can just use this property called convert snake case. It comes under the key decoding strategy because we are decoding something based on the keys, based on the coding keys. So that's all fine, but what if I have my own custom keys? How do I do that? So let's head to the demo. Hope it's visible. So if we have some if we have something like this, it's just an array which contains the same JSON. It lists out all the movies which won Best Director awards in past few years. So if you notice something, it's not in the snake case. Can anyone say what this is? So it's popularly called as kebab case. I don't know why people went with the name. It's popularly known as kebab case, and some instances of spiral case and a case. So to have something like this, we have to use a custom strategy in order to decode this. I'm just giving an example of decoding here. Encoding is pretty much the same. So I was wondering how to do this. Anyone remembers Krusty from 2018 WWDC Embracing Algorithm session?
Yes.
Okay. So Krusty said at the back of my mind, saying, why don't you take a look at the source code, how it's implemented for snake case. So that's what I did. Went ahead and looked at the source code. So if you see, convert from snake case, it just accepts a string and separates it out by a snake case like this or a underscore like this, then takes the element and it compares for the first element. If it is just the only element, just return the string, or if it has a lot of elements, then take the first element and convert it into a lower case, and rest all the components use a higher order function like map and capitalize it. So that's what I try to do, like this, but it started throwing error. So Krusty said, why don't you fix this error before you move ahead? So I told Krusty, no need to fix this error because it's not an error, it's just Xcode behaving weirdly. So I went ahead and turned off this show live issues, and boom, everything was fine. But out of respect, I have to respect Krusty, so I don't want to do this and confuse Krusty. I just put this at the bottom just before I use this convert from kebab case. So here, if you see, so what this does is it accepts an array of custom coding keys. You can customize yourself, and if you leave it by default, it uses whatever that we have in your model to serialize or deserialize depending on the type of conformance that you adhere to. So what this custom coding key does is it accepts, you can create a separate coding key altogether, and it can be a value type. I've used a structure, no need to use enum always. So just store an integer value and a string value, since I'm dealing with array of objects. So remember, a container, it's an unkeyed container, so I have to use an array type here and use the same operation. The default Swift code for camel, the snake case supports multiple other options, like the first element can be a underscore and things like that, but I don't want to do this for my use case. So I'll just go ahead and implement it like this, so that I get a key of my own, and I have defined all the key in the form of camel case so that it works perfectly fine. So let me take a look at the value that it generates. Okay, so we were able to decode it or put it back into in our model. So this is one way where you can customize your coding keys if it is not straightforward, and if you have your own custom types. So next, if you consider the same the JSON, which has nested container in it, Codable, or the decoding and encoding protocol allows you to customize in such a way that you can either create a flat object on your own, or you can just create a nested containers or nested objects within to match this particular data set. So if you want to generate a flat object, no need to worry, just use this nested container if it is a part of this nested group, and ensure that all your the container keys are either the standard types, or at least it supports the codable or decodable protocols. It's not only that, you can just, instead of creating a flat type like this, you can just create a custom type in a way where you want in the same format. So instead of using the nested container, you can just declare this as part of a codable or decodable, and just extract decode if present, like the way you do for other standard types. This is the way of customization that it allows to match for your use cases. How often we see data where we expect a type of data but we end up getting a different types? Like most of us have encountered this. For example, if I'm expecting a duration in the form of an integer and I end up getting string, it won't support, because Swift is type-safe language. So how do we ensure that we don't run into this kind of an issue in production and safely handle in a graceful way? So if you consider this, if you consider the same JSON, and if I want to ensure that it supports type safety and it ensures graceful handling of values, I have written a custom decoding here. So decoding just accepts a key type. There are multiple ways to solve this, but just for this, just use this use case. I have this decode if present method which accepts a key. So first I'll try to decode myself depending on the type that it has. In case if I'm able to successfully decode, I'll just return it to the model. If I'm not, the decoding strategy, the decodable and encodable protocol have different error mechanisms. You can handle your own way. So one such usage is this type mismatch error. So we were trying to decode a type which doesn't match. So in this case, you can handle your own way. I have written some custom helpers to handle it in my own way. So what it basically does is it takes the converter, and depending on the type of data, whether you have a string, integer, double or bool, it gracefully tries to handle it. For example, if you have a number like this, if you have a string like this, and if you want to convert it into an integer, or if you want to convert it into a bool, so you can do this through custom converters. Let's see how it works. So if I just go here and get a data like this, so this time, oops, so this time the string gracefully handles and it converts into an integer, so that you won't end up into a situation where due to type mismatch, the whole model throws an error and you end up having an empty model of your own. Not only this, you can just, so for example, if you want to just say no, list is no. And if you want to store it in a model which is of type bool, and no is not a type defined by Swift. So it automatically converts and ensures that you get a Boolean value of your own. So this is the amount of flexibility that codable and codability supports, so that you can change in any way you want. You can just go ahead and say 1, because 1 is also true and false. It's all up to you how you want to customize yourself, and you just get true here. So one that is pretty new in Swift 5, it supports codability for close range and range operators. If you are having a movie, you should watch a movie. So if you want to watch a movie, you have to buy a ticket. So let's buy a ticket. Who has ticket price? So every ticket can have a maximum and a minimum value, or like nowadays we use the term called surcharge. So let's say it is 150 units and maybe 400 units for a ticket price. Minimum price for a ticket is 150 and maximum price for a ticket is 400. And if you want to support this, you need not have to worry too much. Just use store it here in the form of ticket price, a closed range of type integer, and we have our own key here which says ticket price and closed range. So if you use closed range, oops. Oh, okay, thanks. So you get the lower bound and upper bound by default, so you need not have to worry too much about custom decoding and encoding. So this is pretty new in Swift 5. So if you have any of these use cases, it's highly recommended that you go through, you use this closed range. All right, so can we just write our own custom coders? Yes, we can. So you need not have to use JSON decoder. By default, you can use your own custom coders. Say, for example, if you have a JSON like this or a XML like this, you can use your own XML decoder. It's not difficult to write, but it takes a lot of time. Just this example itself is like 900 lines of code. This XML decoder itself is 900, 800 lines of code. So it's but it takes a lot of time, so I encourage you to go and explore. In case if you are working with Swift on server side, if you are familiar with Kitura and Vapor, they use custom encoders quite a lot. And something new in iOS 13, we have this combine, and earlier during the day we had a talk about combine. So everyone knows that it's a declarative Swift APIs to support which works on values over time. And I think you are quite familiar with subscribers and publishers and operators. So one good thing about is we have a default support for combine, which works with associate types of input type and output. It goes by the protocol top level decoder, and similarly we have one top level encoder. And good news is JSON decoder, at least as of beta 4, Xcode 11 beta 4, we have a default support for top level decoder. It automatically conforms to top level decoder. So if you just use JSON decoder, it automatically works. So you need not have to customize for your use cases. You can just use a JSON decoder if you have an input stream of data or output stream of data, and you can just get the values out of it. So speaking about the performance, Codable is great, but is it really good? Spoiler alert, it's not. So in case if you are dealing with large set of data, say around 10,000 or maybe millions of data, Codable, it's not so good in terms of performance. If you have to deal with such enormous amount of data, Swift buffer, protocol buffer is it's the recommended option. But most of our applications, we deal with millions of data unless we are working on server side. So most of the applications use hardly hundreds or maybe max 1,000 records at a time. So these use cases, Codable is really good, and it takes out a lot of boilerplate code from your source code base. So you need not have to worry too much if you are dealing with just a few hundreds and thousands. In this journey of Codable, we saw the data serialization techniques and the way we have the NS coder and all its drawbacks due to the boilerplate and other negativity. With Codable, you can do a lot of things in a better way. So you can focus more on your objects and things like that, and you can customize yourself. So you need not have to put too much of effort in writing the boilerplate code yourself, like the way we used to do for NS coders. There are some great references in terms of the Swift evolution document itself is pretty good, and also there are some WWDC talks which helps us to understand codability better. Just like almost all my tech talks, I usually end my tech talk with a Subhashitam in Sanskritam, so that's called an epigram in English, or it can be compared to an epigram in English. So I would like to quote, Sadhunam darshanam punyam tirtha bhutahi sadhavaha tirtham phalate kalena sadhya sadhu samagamaha. So always we go and try to visit different places to gain something. So whereas if you meet some people who are scholars or experts in your own field like yourself, that itself brings a merit for everyone. So for this Swift India conference, I think the organizers have put a great effort in bringing all the experts here and meeting at one place. So I would like to thank everyone for their efforts, and thank you everyone for patience. And I'll be putting it in my Git, so you can take it later. Thank you. Or on your objects and things like that, and you can customize yourself. So you need not have to put too much of effort in writing the boilerplate code yourself, like the way we used to do for NS coders. There are some great references in terms of the Swift evolution document itself is pretty good, and also there are some WWDC talks which helps us to understand codability better. Just like almost all my tech talks, I usually end my tech talk with a Subhashitam in Sanskritam, so that's called an epigram in English, or it can be compared to an epigram in English. So I would like to quote, Sadhunam darshanam punyam tirtha bhuta hi sadhavaha tirtham phalate kalena sadhya sadhu samagamaha. So always we go and try to visit different places to gain something. So whereas if you meet some people who are scholars or experts in your own field like yourself, that itself brings a merit for everyone. So for this 5th India conference, I think the organizers have put a great effort in bringing all the experts here and meeting at one place. So I would like to thank everyone for their efforts, and thank you everyone for patience. And I'll be putting it in my Git, so you can take it later. Thank you.